So the first one says, all telephone numbers are preceded by a 3-digit area code in the original Bell telephone system of assigning area codes. The first digit could be any number from 2 to 9. The second digit is either 0 or 1. And the third digit can be any number except 0. In this system, the number of different area codes possible are. Does it say that you can repeat or can't repeat or anything? No. So if it says nothing, unless it's a word, we assume that we can repeat, right? That's how it goes. Unless it's a word, like mathematics, then we know we have only what they gave us, okay? So 2 to 9 is how many options? 8. 0 and 1, and 1 to 9. So it should be 144. Next one, a password from a certain computer program needs to be an arrangement of 4 characters consisting of letters and digits from 0 to 9. So it could be letters, which would be 26, or digits, which would be 10. So we have a total of 36 you can choose from if there's no limitations or restrictions, right? 36. If the letter Y, bless you, is considered to be a consonant, what is the number of 4-character passwords that either begins with a consonant or have no consonant at all? So we have 4-character passwords. 1, 2, 3, 4. They either begin with a consonant, that's it, or, what do I do when I say or? Add, because it's a case, or they have no consonant at all. So they can't have consonants. Okay? I'll start with the restrictions first. So it has to be a consonant. How many consonants are there? Right on. And then our next 3 blanks have no restrictions, so they could be 36, then 36, then 36, right? It could be a consonant, vowel, or a number. What is that? Pardon? No, just this piece. This piece is 979,766. 76? Wow, that's a big number. Okay, this one can't be consonants. So a lot of people go 5, 5, 5, 5. But it doesn't say it can't be numbers. It just says it can't be consonants, right? So it can be numbers or vowels. So they would be 15, 15, 15, 15. What's 15 times 15 times 15 times 15?
50,625.
So you can see that 2 of the answers for this diploma question, one was if I had done the one side, one was if I did the other, right? That was the 2. This one I'm assuming is if they like maybe put 5, 5, 5, 5 instead of 15, 15, 15, 15. Or if they maybe just didn't count that part. But this would be eliminating like something oopsing and adding it up. So it would be 1,030,401. The next one, an airline company requires flight attendants to wear a pair of pants, a shirt, a tie, and a blazer. So they're wearing one of each thing, right? If they wear one of each thing, then I can use the blanks. I can use the fundamental accounting principles, right? But if I used more than one, I couldn't. The maximum number of different outfits a flight attendant could create using the items provided are 3 times 5 times 4 times 2, which is 20 times 6, which is? What's 20 times 6? 120. Numeric response are always filled in left to right like you read. Okay? Not right to left. The number of 3-digit numbers less than 400, so we need 3-digit numbers less than 400. That can be formed with either the last digit being a 4 or a 5. Doesn't say anything about can't repeat, right? So we can. So we go 4 or 5, which is 2. What else is restricted? The front. Yep. can't be a 0, and
Can't
can't be over 3. It can't include 4, right? Because it has to be less than 400. If I put a 4, it's for sure more. Because of the fact this has to be a 4 or 5, right? So we have 2 and 3, which is 2, and then 0 to 9 in the middle, which is, what do we get? 2 times 10 times 2? Oh, why did I forget the 1? Partial, I didn't want the 1 to be part of it. There we go, 60. I omitted the 1 for some unknown reason. Okay, NP2 equals 110. The moment you see this, you have to put it into the formula, right? The formula is NPR equals n factorial over n minus r factorial, which was in your notes. It's also on your formula sheet, so you never have to memorize it, right? Could you have literally just guessed and checked with your calculator? Yeah, because it's a multiple choice. So do you think they're going to give you a multiple choice? No. This will be in a written response for sure, because they'll want to see you actually do some work. Because guessing and checking isn't actually part of our curriculum. So if in the end it was just a guess and a check and you could just do that, they wouldn't be able to give it a question like that, because they would accept, they would understand that that would be probably the way you would do it. So we're going to use the formula. So n is going to go in for n, and 2 is going to go in for r. So we're going to do n factorial over n minus 2 factorial equals 110. So I'm going to show it to you the algebraic way. Do I understand? You probably just punched it in? Yep, because I set you up for that with the multiple choice. So we're going to get n factorial is the one we're going to expand because it's the bigger one. So we're going to get n minus 1, n minus 2 factorial over n minus 2 factorial equals 110. Those cancel, and then I distribute. N squared minus n equals 110. And what did I tell you have to do every single time you have a squared variable with a not squared variable? Get it equal to 0. Move it over to one side. So we're going to get n squared minus n minus 110 equals 0. And then what times what equals negative 110? What plus what equals negative 1? What's it going to be? Negative 11 and 10. So we're going to get n minus 11, n plus 10. So n equals 11, n equals negative 10. 11 works, obviously. That one's extraneous. Okay? So for this one, would you have to have done all that work? No.
Yeah, for sure you would have to do it.
Here, but for the multiple choice you would. For down here, you absolutely would. Yeah. I've seen in the practice questions and such, they'll ask these type of questions in a generic perms and quantums question. They'll ask you to solve for n, and it'll be and I would always put it in a written response to make you show me your work. Okay. How many even 6-digit numbers are there without repetition? I set this one on here because this is the hardest one that we go through that people forget and mess up. Because when it's even without repetition, we need what? 2 cases. Yeah. So we need to have 1, 2, 3, 4, 5, 6. One with a 0, or so plus 1, 2, 3, 4, 5, 6. One with a 2, 4, 6, or 8. So if we have a 0 at the back, we have one option. Then we would have 1 to 9 here, which is 9. And then we'd have 1 to 8 if I kept the 9. So 8, then 7, 6, 5. For this one, we have 2, 4, 6, 8, so we have 4. Then say I keep the 8, I would have 1 to 7 and 9, which is 8. Keep the 9, I would have 1 to 7. But what do I have to remember to do? Bring back that 0 because did I use it in the back? Nope. Did I use it in the front? Nope. So I have to bring it back. I couldn't use it here or here. So it's 8, and then I would keep that, so it'd be 7, 6, 5. Did anyone have the answer to that? Worked out? Have it? No? Someone have it? 68,880? That is the answer. It's a lot of 8s. Right here. Okay. So permutations are when order matters. So when you're listing something in a specific order, and if you listed it in a different order or make a difference, then it's a permutation. So license plates are permutations, right? A telephone number would be a permutation. If it wasn't a permutation, you can put a telephone number in any order, and you get the same person. Would you? No. A code that you punch into on your debit card, that's a permutation, because order matters. Actually, a combination lock should be called permutation locks, because combination locks, the order in which you put those 3 numbers in, matters, right? So permutations are when order matters. So an example might be, you have a group of 10 people and you're picking 3 to be a president, a vice president, and a secretary. Order matters, because they're going to be a president, vice president, or a secretary, right? But if I just had a group of 8 people and I was picking 3 people to be on a subcommittee, and those 3 people didn't have specific jobs, would the order in which I picked those 3 people matter? Nope, they'd be just part of the subcommittee or not. So what we're dealing with today is permutations. So we're going to look, we've kind of dealt with them before with fundamental counting principle. We're going to look at it with fundamental counting principle, and we're going to look at it where we could possibly use the formula as well. So find the number of permutations of the letters in the word kitchen. So we look at the word kitchen. Does it have any doubling or tripling letters? No, and we're going to have to start looking because today we're going to start having repetition. Okay? Here it says if the letters K, C, and N must be together, but not necessarily in that order. Okay? Every time you do a word, it's a permutation, because words order matters, right? If not, loop and pool would mean the same thing. Do they? No. So words are always permutations. Okay? So I need to rearrange the word kitchen where the K, C, and N must be together, not necessarily in that order. Okay. So I have 7 letters. 1, 2, 3, 4, 5, 6, 7. This is how I do the must be together. Okay? I literally take them and put them at the very front of the word, and I hook them together. So it's 3 letters that must be together. So I'm going to go to the front, and I'm going to hook 3 letters together. So I hold them together. And I'm going to put a K, a C, and an N in there. But does it have to be K, C, N? No. If it had to be K, C, N, I'd have 1, 1, 1. We agree? But it doesn't. It can be in any order. So I'm going to start here, and I'm going to say, okay, this one could be K, C, or N, which is 3. Then what do I do every single time? I drop one of them. So then this would be 2, because I could possibly hold that one. This would be KC. And then say I hold the C. This would be a K, so it'd be 1. We agree? So have I hooked KCN together in any order? Yep, I fulfilled that. Okay. How many letters do I have left for the back 4? I have 4. I have I, T, what else? I have H and N. No, H and E. I don't even know what I have. H and E. That looks messy. I, T, H, and E. So I have 4 left. Then I hold 1. Then I'd have 3 left. Then I'd hold 1. Then I'd have 2 left. Then I'd hold 1. Then I'd have 1. Okay? We would be done if it said KCN need to be together at the front. not necessarily in that order. Did it say that? No, it said they need to be together. We agree? So I'm going to show you off to the side here because no one's over right now. But technically, let's say I have K, C, N, and then I have 4, 3, 2, 1, whatever this may be, right? And I've hooked these together. Okay? Bless you. So this is one way. We agree? Okay? So that's one way I could do it. Or I could take KCN and I could plop it between these letters, couldn't I? If I plopped it between these letters, would it make a totally different word? Yeah. Would they be together? Yep. Okay. What if I took them and I put them between these two letters? Would they be together? Yeah. Would they make a new word? Yeah, because we'd have KCN in here. So say these letters, instead of 4, 3, 2, 1, say they were I, T, H, and E. Okay? So if I put KCN in between here, I'd have I, KCN, THE. Would that make a new word? Yeah. What if I had a T here and I put them? It'd be I, T, KCN, HE. Make a new word, right? If I took them and put them in here, it'd be I, T, H, KCN, E. New word. If I put them back here, it'd be I, T, H, E, KCN, wouldn't it? So what you can do is you're going to get this 3, 2, 1, 4, 3, 2, 1. You're going to get it one way, one time with the same numbers. And then if you move it here, you're going to get it 2 times with the same numbers. Here, 3 times with the same numbers. Here, 4 times with the same numbers. Here, 5 times with the same numbers. So remember how this is where I led you into this? Remember how I said it must contain a G? Back in the examples, it must contain a G. And we had a G in the first blank, then we put a G in the second blank, then we put a G in the third blank, then we put a G in the fourth. And we just took 120 and we times it by 4 because it can be at 4 different places. It's the same thing here. This KCN can be at the front, or it could be here, or it could be here, or it could be here, or it could be at the back. So we have to count how many ways that is. So it's going to be one way where it's at the front, or in between here, these two, which is 2, or here, which is 3, or here, which is 4, or here, which is 5. So we're going to multiply by 5, because it's just like moving those G's. Now, the key thing is, it's always one more than the number that isn't hooked. So if this is 4, we're going to multiply by 5. If this was a 7, we'd multiply by 8. It's always one more than the number that's not hooked. So you can count them and go 1, 2, 3, 4, 5. You can count them every single time. Or no, it's one more space than this number. Okay? So our answer is going to be, what's 3, 2, 1 representative of? What short form can I write that as? I'm blasting off, right? 3, 2, 1, blast off, Sander. 3 factorial. And then this one, 4, 3, 2, 1, blast off, is 4 factorial, correct? This is what blows people's minds. Can I take this 5 and make it join the 4, 3, 2, 1 and call it 5 factorial instead? Yeah. I can go 5, 4, 3, 2, 1, blast off. So I can make it be 5 factorial. Instead of writing it as 3 factorial, 4 factorial times 5, I can go 3 factorial times 5 factorial. Because I go 3, 2, 1, which is 3 factorial, and then I go 5, 4, 3, 2, 1, which is 5 factorial. Does that make sense? They're all going to be the same place. I'm going to say yes. Okay, can you type 3 factorial and 5 factorial into your calculator? Could you just type this in and still get the same answer and not type it like that? Absolutely. But the numeric response might be a factorial, b factorial, where a is less than b. So what's, it should be 720, I believe?
Yep.
So this one says number of permutations arrangements where order matters of the letters in the word kitchen if the vowels must not be together. Okay, so what I get is people doing cases where they put the vowels not together. That is the worst way to do it, and you're going to miss a couple. Let's think about it this way. If I said to you, in this school, how many people are not in this class? What would the fastest way to do that? Would it be to run around the school and count people? Count all the people that aren't in here? I'm asking you for the people that aren't in here. Would that be the fastest way to count the people who aren't in here? No, what would be the fastest way to find out the people who aren't in here? Anyone know? Yeah.
Count the people in here and subtract that number from the total.
Yeah, you'd go up, yeah, you go to Mrs. O and you'd be like, hey, Mrs. O, how many people are in this school? And she'd say, I don't know. She wouldn't say, I don't know. She'd tell you what the number is, 850, let's say, okay? And then you'd say, Lepp, how many are in here? And I'd say, 25, and you'd subtract them, right? Then you'd say there's 825 not in here. That's the fastest way. Same thing with this. The fastest way to say if the vowels are not together is actually to take the total ways I can rearrange kitchen and subtract off the ways the vowels are together. Because the total ways I can rearrange kitchen is the maximum number of ways I can make words out of kitchen. Okay? So let's do that. That's like the total number of people in this school, right? Total number of ways to rearrange kitchen. Kitchen has how many letters? 7. So I have 7 blanks, and I would go 7 times 6 times 5 times 4 times 3 times 2 times 1 blast off. So what could I represent that as? 7 factorial. So the number of ways I can rearrange kitchen is 7 factorial. Right? So that's the absolute maximum number of words I can get from kitchen if I rearrange it in every way, shape, form, and it looks different. Right? I think 7 factorial is 5040. Is it? Okay. So with the word kitchen, with this 7-letter word kitchen with no repeats, I can come up with 5040 totally different words. Okay? So let's pretend in this school there are 5040 kids. Okay? If I subtract off all the ones in this class, I'd be left with whoever's left in this school, right? But not in this class. So if I want the ones that are, where the vowels are not together, I'm going to take the total number of words of kitchen, which is 5040, and I'm going to subtract off all the way the vowels are together. And then what's going to be left over? Not together. It's like not in this class. Okay? So whenever you get a not together, it's a standard of excellence, and you have to do total minus them together. Okay? So let's figure out all the ways that kitchen is vowels are together. How many vowels are in kitchen? A, E, I, O, U. How many are in there? There's 2, I and E, right? So we're going to hook them together. You have to put the vowels together. We're going to hook them together. How many options do I have for this first blank? 2. I or E, right? Then how many do I have for this blank? 1, because I leave the I or E in the first one. So this would be like I and E. Leave the E here, this would be I. How many letters have I used up? 2. How many do I have left? 5. So I have 5 for this blank. Then I leave one behind, I have 4. Then I leave one behind, I have 3. Then I leave one behind, then I have 2. I leave one behind, then I have 1. What's the last thing I have to do when they say are together but not at the front? We have to, yeah. Count the places they can move. They can go, exactly. So they can go here, which is one way, or between these 2, 3, 4, 5, 6. So it was one more than the hooked together ones, right? That's what I told you. So it is. Times 6. So this would be the same as 2 factorial times what? 6 factorial, right? Because I have 5, 4, 3, 2, 1 blast off, but I can actually join the 6 with it. 6, 5, 4, 3, 2, 1 blast off. So 6 factorial. I think that's 1440. So absolutely all the words in kitchen I can make are 5040, right? All the ways I can keep the vowels together are 1440 of those words, right? So if I subtract them, what's left over? The vowels not together, right? So 5040 minus 1440, and what do I get? 4600? 3,600? Like something is wrong. Oh yeah, take 1,000 off. Take off. We got 400. 3,600. So whenever it says they're not together, you have to take them total minus them together. Yeah.
When you just multiply the numbers 2 times 5 times 4 times 3 times 2, you get 240, but then when you do 2 factorial, 6 factorial, you get to 14.
Did you multiply by 6?
Oh, no, I didn't.
Right, it's 2 times 1 times 5 times 4 times 3 times 2 times 1 times the 6 ways it can move.
Oh, yeah.
Then look at you, 14 for you. Yeah. Does that make sense? I'm going to star this one. Why? Because I know everyone forgets about it. And it always appears in places that are important. Intentional. If I could put 7 billion stars on there, I would. Because everyone forgets the not together. Okay? So you take total minus whatever it is together that I asked for equals them not together. You're going to try example 2 and example 3, please. This one. So we're looking at oranges. Oranges be arranged. So does oranges have any doubling or tripling letters? Nope. 7 letters that are different. So with no further restrictions, what would it be? 7 factorial, which is 5,040. Because you would just put 7, then 6, then 5, then 4, then 3, then 2, then 1, then blast off, so we have 7 factorial, right? The first letter must be an N. So this one has to be an N, so I have 1. Then I have how many left? 6, 5, 4, 3, 2, 1. Which is 6 factorial. Which is 720. I'm going to teach you something. When you started a number and you count down by 1 until it gets to 1, that's factorial, right? We know that. If you started a number and you count down by 1, you can use the P formula. You can use the P in your calculator. So I can go 6 P. How many did I count down by 1? 1, 2, 3, 4, 5, 6. 6P, 6. And I'll get 720. So when you count down by 1 to 1, you can use 720, and you can use 6 factorial. If you started a number and you count down by 1 but you don't get to 1, you can use the P formula. Okay? So an example would be if I did, which I'm not going to do, but say I did this. Say I had 6, 5, 4. And I didn't make it all the way to 1. Correct? I can't use factorial because I didn't make it to 1. But I can use the P formula. I can go 6P. How many did I count down? 3. I can use 6P3. And it'll give it to me in my calculator. Yeah?
So P, you have to put out like the whole line and dash and you just do 6 factorial.
Nope, you can do 6 factorial. You could do 6P6. And that would all be good. Absolutely. So the reason why we can do that is I know it's a permutation because order matters. It's a word, right? So I can use the P because it's permutation, order matters. I also can use this 6P6 because I'm going down by 1. So what am I saying? I have 6 letters and I pick 6 of them in order. That's what it's doing. And it's a permutation. So whenever you count down by 1 and you don't get to 1, you can use the P formula. That's all. Instead of going like this. Okay? So vowels must be together in the order OAE. 1, 2, 3, 4, 5, 6, 7. They must be in the order OAE. That leaves me 1, 1, 1. How many letters do I have left? 4, 3, 2, 1. How many ways do I have to move it? Now watch yourself because sometimes it does say together at the front or together at the back, and then you're done, right? You don't move it anymore. So don't fall to those ones. Those ones are just, you're done. I have people moving them because you're so used to moving them. Yep. Yes. So this is one way, 2, 3, 4, 5, or like I said, you can always remember that it's one more than the number that's not hooked together, right? So this is a 4, I'm going to multiply by 5. So I can write that as 1 times something is just itself, right? So we don't have to write the ones. And then this is 5, 4, 3, 2, 1. So I could write it as 5 factorial. How else could I write it? 5p5, someone said. I could also write it as the actual answer, which is 120.
Why wouldn't you put 3, 2, 1?
Why wouldn't I put 3, 3, 2, 1 instead of 4, 3, 2, 1?
Since there's 3 vowels, you have to put 3.
Oh, okay, I get what you're saying. It's just because it says in the order. Good question. It says in the order O, A, E. So it has to be in that order. O, A, then E. So I only have one option for this one, it's O. I only have one option for this one, it's A. I only have one option for this one, it's E. Whereas up here it says the letters K, C, N must be together, but not necessarily in that order. So then I'd have 3 for the first blank, 2, and then 1. So this one says it has to be in the order O, A, E. So I have to have O, then A, then E. So I only have 1, 1, 1. Does that make sense? Good question.
Have you ever shown us like 3 letters, but it says not in that specific order for like a minus something?
Sorry?
So will we ever get 3 letters and then it'll say not in that order?
Like these? Like this one? KCN up here?
Yeah, but instead of not necessarily, it's not in that order.
No. I get what you're saying. No, that would just get crazy. You'd have to remember to do the whole thing and then take off. Yeah. Yeah. So this one says how many of the arrangements, I'm going to sneeze and I want it to go away. Pineapple, 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 pineapple. Make it left. Okay. In how many of the arrangements of the word brains are the vowels together? So we have 2 vowels. 1, 2, 3, 4, 5, 6. So I'm going to hook them together. Does it say in any order? Nope. So I can have 2 vowels, A or I here. Hold 1. 1. Then I have 4, 3, 2, 1. And then I have to multiply by 5 for the moving of it, right? 1, 2, 3, 4, 5. So I get 240. What if it said the vowels can't be together? If I said they can't be together, I'd have to find the total. How is the total way of brains? Brains is 6 letters. What's the absolute total with no restrictions? I could arrange that. Yeah, 720. So it'd be 6. So if I said not together, just as a practice, I would do 6 factorial, 720, the 6 ways I can rearrange brains, absolute maximum, right? And I'd subtract off the vowels together, right? 240. And I'd be left with 480, I believe. Okay, we're going to look at example 4. Yep. Yep. In how many ways can 3 girls and 4 boys be arranged if no 2 people of the same gender can sit together? So, how many do we have? 7. 1, 2, 3, 4, 5, 6, 7. Does order matter in this case? Yeah, I'm arranging them. This is a huge giveaway that it's a permutation. Arranged. If I'm arranging something, I can literally see that I can change it into something else, right? So how can I do this so that no 2 people of the same gender sit together? What would I have to do? Yeah.
Would you alternate boy girl?
Right. What would I have to start with first? Because there's more. Yeah. So I'd have to go boy, girl, boy, girl, boy, girl, boy. Which is 4. I'm going to make the boys in blue. So 4, then I sit a boy down. 3, sit another boy down. 2, sit another boy down. 1. With girls, I would have 3, sit a girl down. 2 for this one, sit 1 girl down. 1 for this one, right? So I could go 4 times 3 times 3 times 2 times 2 times 1 times 1. Or if I look at the blue, what could I represent the blue with? Yeah, 4 factorial, exactly. Andrew, what could I represent the blue with? The blue number? 3 factorial. Exactly. What does that get me? 144. Thank you. Okay, I'm changing the question for you to do. There's 4 girls, 4 boys. They must alternate. Tell me how many ways that happens. 4 boys, 4 girls. They must alternate. Give me the answer. Press that. 4 boys, 4 girls. What do you start with? You could start with a boy, couldn't you? Some of you probably did, because we started with boys. What else could you start with? Girl. If you looked at a picture, if it started with boys, it went boy, girl, boy, girl, boy, girl, boy, girl. Or you saw a picture and it went girl, boy, girl, boy, girl, boy, girl, boy. Would it look different? Yep. So most of you will get half the cases. So when they're even, when it's 3 and 4, it's easy. You can only arrange them one way. When it's 4 and 4, 1, 2, 3, 4, 5, 6, 7, 8. So 4 boys, 4 girls. It's going to be boy, 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 girl, girl, girl. Which is true. 4, 3, 2, 1. 4, 3, 2, 1. Which is technically 4 factorial times 4 factorial, is it not? But could I not go girl, boy, girl, boy, girl, boy, girl, boy, and it look different? Yeah. What numbers would you get for that? 4 factorial and 4 factorial, wouldn't you? So what do you have to do with the answer most of you got? Times it by 2. Because you have this situation as well. Or you could show both cases and add them, right? You're either going to go 4 factorial plus 4 factorial, 4 factorial, or you're going to go 4 factorial times 2. So a lot of the time people only have half cases. Do you see how that's a problem?
Can you square factorials?
You square factorials? No. Well, yeah, you should be able to. Yeah, if you put in brackets. If you don't put in brackets, it depends on the calculator. Yours might be okay. So what's 4 factorial times 4 factorial times 2?
1,852.
This is another one I give a big star to, because people forget that you have to look at it and say, is there another way I could change it? And it'd be something different, right? And pictures often get people. Arranging things in an order, if they're even and they're alternating, you can flip them and get them another way, right? If they're an odd number of things and you're alternating them, you can't get them a different way. There's only one way to do it. 6 actors and 8 actresses are available for a play with 4 male roles. It should say, sorry, this is, I forgot to keep changing every single year. It should say 4 different male roles, just to be specific. And 3 different female roles. How many different cast lists are possible? So we have to decide, this is how you can tell if it's a permutation or a combination. First off, you're in the lesson of permutation, so it's a bit of a dead giveaway it's permutation. But how can you tell that it's actually a permutation? It's based on what you're choosing. So you're choosing 4 different male roles. So if you pick the people in, those 4 people in a different order, do they get something different? Yep. Permutation. Order matters. If it was 4 of the same male role and I picked those 4 people, would it matter what order I picked them? No, they get the same role, wouldn't they? So the different part here is what makes it a permutation. Because order matters in which you pick them. The easiest way to do this question is choose males from males and females from females. So we have 6 actors. That's the total. We said it's a permutation, isn't it? Right? So we can do it this way instead. We can go P, 6P, and how many male roles are we picking? 4, because they're actors. And we need 4 male roles and 3 females. For how many? 8P3. And means we do what between these two? Multiply. Because and add sound like they should be friends, but remember we put an X through them. They are not. And means to multiply. Could we have went like this? Picked our 3 options, our 4 males, and said, oh, I need 4 male roles. I have 6 males for this role, 5 males for this role, 4 males for this role, 3 males for this role. Yep. Could I said 8 females for this role, 7 females for this role, 6 females for that role? Yep. Did I tell you if you started a number, go down by 1, you can use this? If you started a number, go down by 1, you can use that. They're the same thing. Which one's better? It's a trick question. Whichever one you can do and get the right answer to. Neither of them is better than the other. Because what do they result in? The exact same answer. So which one's better? Neither of them. Now, if they ask you for it in, if they go something like this, 6PA times 8PB, and you only know this method for numeric response, what's the problem? You can't do this, right? So we do need to know the P ones as well. Okay? Tomorrow we finish up repetitions. What I want to show you is your homework. So we haven't done repetitions. So that's whenever I give you a word with doubling letters, tripling letters, something like that, you can't do those yet. Okay? So like aardvark, Vancouver, mathematical. If I give you mapping questions like this, you can't do those. Okay? That's it. That's all you can do. So, this is repetitions as well. This is going to be your homework. There's one thing I'm going to cross off on it. The homework page is located under Perms and Cons. In your lesson, it's called Perms and Cons. That's what I say. On the side, you know, when you go to, you pick the topics on the side in your Google Classroom. You can pick the Perms and Cons topic. You're going to pick September 3rd, because today is September 3rd. So you're going to pick that one. And in there I have the textbook pages with the answer key. Okay? If you look at it, you're like, I don't know how to do repetitions. It's because you don't. So this is going to be the exact same lesson assignment for tomorrow as well. So just do the questions you can, which are the ones that just don't have repetition. Okay? There is one in here that I know I can't make you do, and I leave it on here every year. So this is an assignment for 2 days. 7B, sorry, this one I need to remember to take off always. You need to know the polynomial unit in order to do that question. So please take off 7B. Okay? So if there's anything like number 5, for example, number 5 has doubling and tripling letters. You won't be able to do number 5 tonight. This one you're going to have to wait for. Okay? And number 8, you can't do. Number 11 has some identical things in it as well. So that's another one you're not going to be able to. If it says identical, will you be able to do anything that has identical things in it? No, because identical things are repetitions, right? And we haven't done those. Okay? So work through it. If you get stuck on something, just don't do it until tomorrow. Okay? If you're not 100% sure. So that's the homework for today and tomorrow. And I can show you.